Dear students, welcome back to my second video. In the first video, we had discussed about validity of Ohm's law. We had discussed about resistance. And again, what are the factors on which the resistance of a conductor depends? That already you had studied in your class 10. Now let's try to recall that one. The factors on which the resistance depends. The resistance is directly proportional to the length. R is proportional to L, the length of the conductor. More the length of the conductor, more will be the collisions of the ion with the atom, with the electrons with the ionic core. So resistance is directly proportional to length, and resistance is inversely proportional to cross-sectional area. More is the cross-sectional area, less collision will be there, so less resistance. Combining these two factors, what we got is resistance is proportional to length divided by cross-sectional area, or resistance is equal to rho L by A, where rho is resistivity of the material. So already in class 10, we had also again defined resistivity and what is its SI unit. Once again, I am defining again here. It is defined as the resistance offered by a conductor of unit length and unit cross-sectional area, and its SI unit is ohm meter. So when we study the validity of resistance, we also know that R is equal to ml divided by n e squared tau A. Now putting the expressions, let's try to find out the expressions for resistivity. Comparing the above equations of resistance is equal to ml by n e squared tau A with resistance R equal to rho L by A, we get rho is equal to m divided by n e squared tau. So what does this mean? This means that resistivity depends upon the number of electron density, but here resistivity will be inversely proportional to n, the electron density per unit volume. Resistivity will be inversely proportional to the relaxation time, and the third factor is resistivity is independent of dimension of the conductor. Why? Because resistivity does not depend upon the area A. So resistivity, we can say that it's independent of the dimension of the conductor, but depends on the temperature and other physical constant. Now let us study about temperature dependence of resistivity. Now this temperature dependence of resistivity, we had not only that resistivity, but resistance also depends upon temperature. In my first video, I had already said about that the resistance of a conductor also depends upon the temperature. Now, temperature dependence of resistivity. Let's see the first one in case of metal. In case of metal, number of free electron is almost independent of temperature. As temperature increases, the free electrons which is moving towards the positive terminal of the battery, they collide more frequently with the metal ion. When they collide more frequently with the metal ion, what will happen to the relaxation time? The relaxation time tau will decrease. Then when tau decreases, what happened to the resistivity? Tau and resistivity rho are inversely proportional. So resistivity increases with temperature. With resistivity will increase as tau decreases. The relation between resistivity rho and temperature T is given by rho is equal to rho naught 1 plus alpha T minus T naught. From where we get this one? We get it from the increase in resistivity is directly proportional to original resistivity. Increase in resistivity will be directly proportional to the rise in temperature. Combining, we get this one. And here in these equations, what is rho naught? Rho naught is resistivity at temperature T naught, and a constant comes which is known as alpha, which is temperature coefficient of resistivity. So temperature coefficient of resistivity alpha is rho minus rho naught by rho naught T minus T naught, or 1 divided by rho naught d rho by dt. and SI unit of temperature coefficients of resistivity is degree Celsius inverse. Thus, if you are asked to define temperature coefficients of resistivity, then you can define it like this. Temperature coefficient of resistivity can be defined as change in resistivity per unit resistivity per unit change in temperature, and its SI unit, once again I am repeating, is degree Celsius inverse. Now when we plot a graph between resistivity and temperature, the graph is going to be non-linear at low temperature. For metal, again, this alpha value is very small and it varies non-linearly with temperature. So when we plot a graph, we will get a graph of the form like which is non-linear in shape. The graph where I am drawing it here, you will get a graph of this form. And for metal, like if it is good conductors like copper, same graph will be obeyed. Same graph will be there. It's non-linear. And in your NCERT text also, resistivity, you are asked to draw a graph showing the variations of resistivity with temperature for copper. So you will get a graph as shown here. Again, same way, just like resistivity depends on temperature, the resistance also depends on temperature. The change in resistance, or simply the resistance that you get at temperature capital T, will be equal to R naught 1 plus alpha T minus T naught, where R naught is the resistance at temperature T naught, the smaller temperature, and alpha is temperature coefficient of resistance, or simply I can write alpha as R 100 minus R naught by R naught into 100, where what is R100? R100 is nothing but the resistance at 100 degrees Celsius. That means you have to take T as 100 degrees Celsius. T naught should be taken as 0 degrees Celsius. So that is T minus T naught is nothing but 100 minus 0, that is 100, that is a change in temperature. This is about the variations of resistivity with temperature, and same goes for resistance also. If you are asked to plot a graph showing variations of resistance with temperature, the same you will get. Now comes to variations of resistivity in case of alloys. Resistivity with temperature for alloys. For alloys, we have a very high value of resistivity, and they are less affected by temperature, and at the same time they have a very small positive value of alpha, and there is a linear relations between resistivity and temperature. So if you had to plot a graph between resistivity and temperature, you will get a linear graph as shown in the figure. For semiconductor, relaxation time of a semiconductor is almost independent of temperature, but the free electron density increases exponentially with increase in temperature. Therefore, conductivity of a semiconductor increases with increase in temperature, that is, resistivity decreases with temperature. And this resistivity again decreases exponentially with temperature. So if you had to plot a graph, you will find that resistivity decreases with temperature. All these three graphs you will find in your NCERT text, and this graph is very important from examination point of view. Why? Mostly, even though it carries less mark, they used to ask it, and at the same time what comes in the exam very often is that why are alloys used for making standard resistance? These questions comes in the exam. So what you have to say is that alloys are used for making standard resistance because they have high value of resistivity, less affected by temperatures, and they have a positive value of temperature coefficients of resistance, which is very small. Now the next topic which I am going to pick up is resistors and the different types of resistors and the color code of carbon resistors. So resistors are the material which gives a which gives a definite value of resistance. And there are two common varieties of commercial resistors. One is known as a wire-bound resistors and another is known as a carbon resistors. Only carbon resistors is there in your syllabus. So what are these carbon resistors? Carbon resistors are not made from a mixtures of carbon black, clay and resin binders, which are pressed and then molded into cylindrical rod by heating. Then these rods are enclosed in a ceramic or plastic jackets, and this carbon resistor, which is giving a definite value of resistance, is widely used in electronic circuit of radio receivers, amplifiers, etc. And they have the following advantages. What are the advantages? They can be met with resistance values ranging from few ohms to several million ohms. They are quite cheap and compact. They are good enough for many purposes. The color code of carbon resistor. Color code is used to indicate the resistance value of the carbon resistors and its percentage of accuracy. Here in this diagram, I am showing a carbon resistors, and here I had drawn 4 rings. In some carbon resistor you will find only 3 rings also. The first ring colors will be there. Colors are being etched here, which I had drawn. It has first significant, second significant, decimal multiplier, like that here I had shown. Now what does this first significant, second significant, decimal multiplier tolerance indicates? Now let us see that in case of here the rings are of different colors. It may be of same colors, but colors indicate what? Colors indicate the value of the resistance. If you know the colors that has been shown by the carbon resistor, then you can definitely see that this carbon resistors is having a resistance value of this, having a tolerance value of this, like that you can easily read. Now how to read the color code of this carbon resistor is that here altogether we are having here how to read. Here the color sequence and all this has been given. Here the color sequence has been given like this, that out the black, brown, red, orange, yellow, green, blue, violet, gray, white. Now there will be gold, silver and no fourth band. What does all this indicates? Let's see. Now before I start with this, I had in the first slides I had already said that these rings are made up of different colors, and if the first ring, let us suppose that if the first ring is yellow, then what does it indicates? For example, I had given one here, like I had shown it here, Y. Example, I had given YRB gold. What does this means? Y. Y stands for yellow. And what is the value indicated? Numbers allotted to yellow. Yellow in the, look at the chart carefully. Numbers allotted to yellow is 4. Then second ring is red. Second ring comes out to be, second significant figures comes out to be red. So what is the value indicated to red? Red is 2. So, and therefore you are going to write for Y it is 4, next is red, so that means you have to write 2 for red, therefore you get 4, 2. And the third is B here. B stands for blue. Third chord here, what does it say? It said that it is the decimal multiplier. So decimal multiplier, third is blue. Blue, what is the decimal multiplier? From there you will find that the decimal multiplier is 10 to the power 6. So that means when you, what is the chord of that resistance? What is the value of that resistance will be 42 into 10 to the power 6. And what has been given? Gold. The fourth color, which we call it as tolerance. Tolerance value, that means tolerance value, the resistance may vary, how much variations it may be there. If it is gold, it is plus minus 5% tolerance is there. This is how we have to rate. But look at the values, how has been it has been given, and look at the color. Black, the numbers allotted, letters that has been given is B. brown also, first letter it starts with B, red starts with R, orange starts with O, yellow starts with Y, G, green, G is for green, and blue starts with B, violet, it starts with V, gray, it starts with G again. Now then, how to read the color? Read the color then. What are the numbers allotted? Also you see, black 0, brown 1, red 2, orange 3, yellow 4, green 5, blue 6, violet 7, gray 8, white 9. And if it is going to be multiplier, black will be 10 to power, for black it will be 10 to power 0, brown 10 to power 1, red 10 to power 2, orange 10 to power 3, yellow 10 to power 4, green 10 to power 5, blue 10 to power 6, like that. Up to white it is 10 to power 9, and if it is gold it will be 10 to power minus 1, silver it will be 10 to power minus 2, and the tolerance value, the others are quite small. The tolerance value for gold and silver is plus minus 5%, silver is plus minus 10%, and if there is no fourth band it will be plus minus 20%. Now if a color code has been given here, look at the color code of the carbon resistor. In bulk it will be manufactured and it will be sent out with the help of this ring marked in different colors. So how to read? When you had to read what is the first color, you had to know what is the second color ring, what is the color of the second ring, what is the color of the third ring, like that. So by knowing the colors you can put the value, but it becomes difficult for you. So what you have to do is that, and the numbers has been assigned in such a way that it starts from for the different colors. There are 10 colors which has been shown, assigned the numbers starting from 0 to 9: black, brown, red, orange, yellow, green, blue, violet, gray, and white. Quite an easy one. And the numbers allotted are 0, 1 up to 9. 10 colors it has been given. So when the colors has been given, how to read is quite easy. For black you take B, for brown you take B again, the first letter BB, red R, O, orange you take O, yellow you take Y. So I can say that if I had to take, then I can say it's BB Roy. Next comes G. So you take green G. Therefore, I can write it as BB Roy of Great Britain. Green G, great. Blue B, it will be Great Britain has very. Violet V, very. Gray, it will be G I had to take, so I take it as good. And white, W I had to take it, and I can say it as wife. So I can say BB Roy of Great Britain has very good wife. From here you write 0, 1, 2, 3 up to 10 wife. That is white indicates it, and therefore when you put the value here, while you read again, I'm coming to the first slide. So when you give the first ring, what is the color? That will be the first significant figures. So same the example I had said, if the first figure is what? If the first figure comes out to be, here again you come to it, yellow, then yellow indicates what? Yellow indicates 4. Second significant second ring in is red, then it will be 2, and the third ring is blue, then it is going to be multiplier, so it will be again 10 to power 6, 42 into 10 to power 6, and the fourth ring is a gold is plus minus 5% tolerance, like that. If only 3 rings are there, then there will be 42 into 10 to power 6 ohms, plus minus 20% tolerance. This is how we read the resistance of the carbon resistors, which we are using abundantly in electronics circuit.